All right, everybody, we're going to give this new technique of shooting videos a shot with Unit 0 Day 4 on proportional relationships. Now, I am outside, so if the camera is a little wobbly, I apologize. It's a windy day, but we're going to see if we can make the most of it and keep this under 10 minutes as well. Now, what you'll notice here is what you're studying is what's called a proportional relationship. Now, a proportional relationship is simply a relationship between two different variables. Now, those variables can be represented many different ways, but again, a proportional relationship is a relationship between two different variables, and how they relate to one another is what makes them proportional. The fact that they relate to one another at all makes them a relationship, but proportional is a special thing, and we'll talk about what that is. Now, proportional relationships, before we get into the notes that I know you're looking at right now, let's start off with, well, what a proportional relationship is. Let's imagine you have a part-time job and you work for $10 an hour. If that's all that goes into your job, if you work 1 hour, you get paid $10. If you work 2 hours, you get paid $20 and so on. This is considered a proportional relationship because for every hour you work, you get paid a certain amount of money. But the important thing is that if you work no hours, you get paid $0. That's what defines a proportional relationship. This is a non-proportional relationship. It's not bad, it's just not proportional. You work for $10 an hour plus a starting bonus of $50. That starting bonus changes things. That means before you've worked any hours, you've already made $50. That makes it not proportional. Now, I'm going to try to show off some different examples as we go, but anytime that initial value changes, again, in other words, if this were any other scenario, the $10 could be 9 or 8 or 12, that doesn't matter. The 50 could be 75 or 100. It could even be negative 50, such as you have to buy a uniform before you've actually made money. That might be a negative value here. The fact that there's any value here whatsoever means it's not proportional. So again, proportional is very simple. Non-proportional is not as simple. Now, what makes this simple is a unit rate. This value right here, and no matter how you use it, either proportional or non, this is called a unit rate. And a unit rate is a rate that very simply has a denominator of 1. So you'll notice how I have this written here. This is $10 per hour. I could write that a different way. I could say it's $10 per 1 hour. And you see that you have a 1 in your denominator, and that's what makes it a unit rate. Now, unit rates are often used to describe things that are like a unit cost. Often per unit cost is a really, really common one. These would be examples of unit costs. Other examples might be cost per hour or rate per hour, how much I get paid per year, how much I get paid per hour, like again we've shown here, or even in a car, how many miles per hour I drive. If you've seen a speed limit sign, that is an example of a unit rate. Now, your task in this small unit is not really to boil those things down. It's not even always to compute what a unit rate is. It's in fact to do something and to identify what a proportion is. So let's identify one more time a different representation of proportional relationships. I've already shown you the example where if you work for $10 an hour, it's a proportional relationship. Let's show you what that would look like in 3 different forms. The first form would be graphically. If we're looking at that relationship graphically, what I would expect to see is a graph that is first a straight line of some sort. It might be really steep or it might be somewhat shallow, but I'm going to expect to see a straight line that starts at the origin because that is the indicator of a proportional relationship. If your line goes through point 0, 0, then you have a proportional relationship because if I work 0 hours, I get paid $0. That's how that works. Now, since I don't have any scale here, I'm going to go ahead and make one up here. I'm going to say that if I work for 1 hour in my previous example, then I get paid $10. Now, normally these axes will be given to you, but imagine that I put a dot right here and I put a dot right here indicating $0 for 0 hours. And if I drew myself a straight line, oops, I missed it, so I'm going to fudge it a little bit. If I drew myself a straight line through here and extended it forever, that would be an example of a graphical drawing of a proportional relationship. Again, the key component here, it goes through the origin. That's what makes it proportional. If you see a table and you're not sure if it's proportional or not, here's a hint. Of course, I'm not going to give you the easy one. If 0, 0 is your first pair, it is automatically proportional. That's fine. But what if it isn't? What if I have something different and I have a 1, a 2, and a 5, and over here I have a 6, a 12, and a 30, and I'm trying to decide whether it's proportional or not? Well, here's how you do it. You simply divide your y value by your x value for each pair, and it should always be exactly the same thing. Look what that looks like. In the first pair, the y value divided by the x value equals 6. In the second pair, the y value of 12 divided by the x value of 2, equals 6. And in the third pair, our y value of 30 and our x value of 5 divide to be 6. And notice how they're always the same? Because they're always the same, it is proportional. Very, very easy to check. So far in a graph, if it goes through the origin, it's proportional. In a table, if this number, which by the way is called a unit rate, which we've already talked about, in this example the unit rate is 6 whatevers, but it's 6, then the unit rate is always 6, then we have a proportional relationship. And then finally, when you're creating an equation that describes a proportional relationship, what you do is you write this in the form, and I'm looking at the notes you need to fill out here. You're going to first calculate the unit rate, which we've done by dividing y over x, and then you're going to write an equation in the form that looks like this. Y equals mx. Very, very simple. And the m stands for unit rate. So in our example right here, if I were going to write an equation that would describe this pattern, I would write an equation that looks like this. Y equals 6x, and that's all there is to it. And over here on my left-hand side, where 1 hour produced $10, I would write y equals 10x. And again, that's all there is to it. That's what a proportional relationship looks like. So now you've seen 3 different variations. You've seen the graph that goes through the origin, the table that has the same unit rate when I compare y divided by x each of the times, or you see an equation that is nice and simple and concise in this form with a number in the m spot, or the unit rate spot. Now, as I go to my next slide, here's an example of what non-proportional relationships look like. These would be examples of things that don't follow that trend, and you're going to notice that I'm going to do these in black so they stand out. If I have, there's leaves flying from the sky here. If I have a graph that starts anywhere other than the origin, even if it looks like it has that same beautiful straight line as we did before, this is going to be why it is non-proportional. It's non-proportional because it does not go through the origin, so therefore this is automatically not proportional. Once again, it's not bad, it's just not proportional. In a table setting, you might have something like 4 with a 7, and let's see, 5 with a 10, and a 7 with a 16. Now what I would observe here is that if I divide my y and x, 7 divided by 4 is 7 divided by 4, that's going to be a decimal. 10 divided by 5 is going to equal 2, and 16 divided by 7 is once again going to be a decimal. So even though I haven't even identified what the decimals are, I know they're not going to equal 2, so therefore once again, not proportional. If they were all looking like fractions, I might grab a calculator or do some long division and figure out that what the decimals actually are, but in this case I don't even need to do that. And then finally, non-proportional relationships, again, they will miss the origin, they will not have a consistent y divided by x, and they'll follow a different form altogether. They'll still have mx, but then they're going to have something added or subtracted onto the end of it. They're going to have some extra stuff there. And when they have that extra stuff, that means non-proportional. Now, I'm going to bring back a slide from before, and then we're almost done. Since we've been talking about equations, let's look at our first example. You work for $10 an hour. $10 an hour is your unit rate, and we've been using unit rate as the letter M. So this first equation, if I were going to describe it, would be y equals 10x, and that's it. That is proportional, right? Notice no extra stuff at the end. The non-proportional starts out the same way. You work for $10 an hour, So we're still going to begin y equals 10x. Things look proportional, but then what we recognize is, but you get plus a starting bonus of $50. This is the pattern here. You notice this extra stuff. This has meaning, but in our context right now, all we really care about is knowing that this is proportional because it doesn't have anything else on it, and this is not proportional. And that's something that you should take away from this small lesson. Now let's see if we have anything else to offer. We've gone over the non-proportional. And finally, how to write an equation. I think we've done this already, but just in case. If I see a graph that's already created for me, what I would do would be, since we're looking for the unit rate, I'm going to go over to the first space that I see, and I'm going to travel up until I hit my line, straight up, not on a diagonal, but straight up until I hit my line, and then I'm going to go straight over until I hit the line on the left. So I start at my x-axis, I travel over to my y-axis, and whatever number I hit, notice how it looks like I'm going to hit the number 6, that is my unit rate. So I know two things here. I know that my unit rate is 6. I observe that it goes through the origin, so I know it's proportional. So I'm going to write my equation, y equals 6x, and I'm all done. And what this does for me is it tells me that every time I find an x value, like a 2, a 3, or a 4, if I multiply it by 6, I'll get the y value over here. And to give you an example, let's try number 4. 4 times 6 is 24, and watch this. If I come straight up, and I know I don't have a ruler, so forgive me if I'm a little bit off. I come straight up. When I go straight over, I hit, and my lines aren't perfect as you can see, but I hit or should have hit 24, exactly as predicted. So again, how to write an equation using a graph. And here we go, one more. How about 1 and 3, 2 and 6, 8 and 24, 10 and 30. So these numbers don't necessarily have a specific pattern to them, but I know they're proportional because 3 divided by 1 is 3. Again, y divided by x. Here goes one of my papers. 6 divided by 2 is 3. 24 divided by 8 is 3. And 30 divided by 10 is 3. The fact that these are all the same means they are proportional. That means that they are my unit rate. And if they're my unit rate, you can guess that my equation is y equals 3x. All right? So there you go with proportional relationships. Again, look for lines or patterns that have some consistency and or go through the origin, and you have yourself a proportional relationship. Good luck.